Finally move on to some other topics. So let me see what else is good, or what else is important in this class. Programming is kind of important. I don't want to talk about flowcharts, stuff like that, but I do want to talk about programming a little bit. So I'm going to talk about programming next. Data processing is something that you guys won't see for the most part, so I will kind of do that one later. So the next topic is programming functions, overview of languages, flowcharting or pseudocode techniques, typical computer instructions, and so on and so forth. It looks really super dry, but that's not the way I'm going to teach it, because I can't stand it either. What I would do instead is I would use Scratch to introduce all these topics. Scratch is interesting. Okay, let me see if I can just play this. I think we have done this before. Yep. Okay, so that's a kind of quick 38-second introduction to Scratch programming. It is available. It's a Java-based program, which means it is available to Mac OS X, Linux, Windows. Just about any practical modern platform should be able to run Scratch. Now, because I have just recently, like yesterday, changed my 16 gig hard drive, so that's why it's not installed yet on this computer. And the fly is bugging me, literally. I'm going to skip because I'm under 13. There we go. They have an installer for Ubuntu, which also runs in Debian as well, or anything that is Debian-based. So I'm just going to install this. I'll save the file first. Then I have to install it.
What's your favorite programming language?
My favorite programming language? I usually don't have a preference. In other words, I don't really name one as my quote-unquote favorite programming language. You basically just pick whatever is available and best for the job. So depending on what I'm doing, I can use a different programming language. For general programming, like automating, stuff that I usually do by hand in the system, I now use Python. I used to use Perl, and I'm now in the transition to Python. Just because Python is a more modern programming language, and it will have support for the next 10 years, whereas Perl is not a dying language, but it seems like most of the new development are on Python instead of Perl. So from the practical standpoint, it makes sense to transition to Python because it is it's an active language. For systems programming, when I need to write programs that run really fast and efficiently, I use C and C++. When I program those little tiny MCUs for embedded systems, sometimes I have to drop down to assembly language programming because I don't have a choice. I have to do that. So it all depends on the job, what I'm doing. Java is not one of my favorite programming languages. It's okay, but for the most part, it's not really my favorite. And we have the application here. I'm just going to go ahead and install that. And you guys can see how easy it is to install a program in Linux. It's really literal. Is one single line of command. So I just go to my folder where the file is located. And then I run this command, sudo dpkg-i, name of the program. assuming I have everything that it depends on already installed, this should be fairly easy. Yep.
What would you say would be the easiest language to pick up, just starting? Would you say it'd be Python or Java or what? Easiest to just.
Java is a good general programming language. Python, they are not exactly the same thing, but they do overlap a lot. In other words, if you want to do, say, web scripting, you can do web scripting in a variety of languages. Most people start with PHP because the transition from HTML to PHP, there's no transition. A null or simple dumb PHP program is an HTML file. Then you can start to insert a PHP code, on a very gradual basis. If you start with Python and you want to generate an HTML, page, it takes a lot more work than the other way around. But for system stuff, I use Python for the most part. Java is a good programming language, because it has a lot of support. It has a lot of, the installation base is huge, which means if you know how to program in Java, the chances of getting a job is much higher than, say, other programming languages because so many programs are already written in Java. Okay, so it's complaining because I have an older version of Pulse Audio installed on this system. Okay. Let me find out if I can just force it to install even with false depends. So apparently Ubuntu is already using the newer version of Pulse Audio, but not with Debian. And therefore we have a little bit of a problem. It's complaining, but I told it, yes, go ahead and install it anyway. Don't do that if you're not sure about what you're doing. That can potentially break your whole system. Pulse Audio is really just the audio part of the system. So the worst thing that can happen at this point is I lose the ability to use audio in Scratch, which is not a big deal. Okay, but if you force dependency when you're installing, say, drivers or major components of an operating system, that can cause problems, like really big problems, like your computer won't boot anymore. Okay, so let's go look for that, and I'm not sure where it puts it. Hmm? Nope. Or I can just try to see if I can find Scratch. Yep, there we go. Scratch. And there you go. This is the Scratch interface. I'm sorry that I had to spend a little bit of time to convince the system to install it, but now it is installed. This is the whole GUI. Okay, it opens up like this. This is what they call the canvas. Okay, the canvas is basically the area where the program runs. This is called a sprite. Okay, a sprite is basically an object on the screen that you can control by writing a program, that runs and control the sprite itself. You can have one sprite, you can have two sprites, you can have many sprites in a single Scratch program. They can all live on the same canvas. In other words, they can bump into each other, and you can write your program to detect that they have bumped into each other, and they can do something different. On this part here, on the left-hand side, we have the tools. Okay, so these are the basic building blocks of a Scratch program. I will, illustrate, the basic ones, and then we can talk about the more, difficult, or not difficult, but the more interesting ones. The middle part here basically is where your program goes. Right now it is empty because we are starting from scratch, literally, and there's no program running at this point. Over here at the lower right-hand corner, we have an area where you can click on different things so that the program will correspond to that thing that you just clicked on. In other words, this is not called a canvas, it's called a stage. The stage also can run its own script, okay, which is kind of great because there are certain things you can control in the background while you have sprites running around and doing their own things. Okay. Are there any questions at this point about running Scratch? Okay. Does it look kind of intimidating, or does it look? Yeah, it looks like it's going to be okay. Well, we'll first find out what we can do with this. Now, what we can do at first is to look at stage, and we can click on sprite 1 because these are the only two objects for any type of empty Scratch program. They all have these two objects: the stage itself and the sprite, the first sprite. They're both created by default. So since I clicked on sprite 1 last, it is now whatever I specify here will now be applied to sprite 1. Now you don't even have to run the program. Something you can do without even running it. In other words, you can look into looks. Okay, these are basically each tab here controls it will display a particular panel that gives you all the tools of that category. Some people in the back may have problems reading it. The first one is motion. In other words, it controls the motion of the sprite, moving forward, moving backwards, turning, and so on and so forth. The second tab is looks. You can change the costume of the sprite. In other words, a single sprite can have a number of costumes associated with it. The reason why they have multiple costumes, quote-unquote costumes per sprite, is you can emulate animation this way. Okay, if you time the changing of the costume and you draw the costumes in a way to emulate animation, you can make this little cat appear to be walking. Okay, you can have the say block here. Now this one, Scratch is nice in a way because you can just click on one of these action items and it will just do the action item even though it is not a program. I don't have a single program right at this point. I can click this block here and I can just repeat what it's saying. This block says say hello exclamation point for 2 seconds. Let's go ahead and find out what it does when I click it. Okay? In other words, if I click this, the sprite just say hello for 2 seconds. In other words, if not for anything else, you can put together a very crude animation, like a comic book type of animation. Okay, you can design your sprites. They can kind of walk together, and they can talk to each other. Turn away. One can turn away, walk away. The other one have change to an angry face and whatever. Yep.
So this could be potentially used as a storyboarding.
Exactly. It's not designed for that purpose. So in other words, there are certain things you cannot do, and for one thing, it is 2D only. It's not a 3D type of program. But yes, you can definitely do it that way. You can introduce interaction or interactive components, step by step. Maybe initially, the sprites would just kind of do the conversation thing, or just walk a few steps without any full interaction from the user. But later on, you can have the user to specify, okay, what should this particular sprite do next? You can select one of the options. It can detect like a mouse click. It can also detect events on the keyboard. So there are many ways to get the user to interact with the program in Scratch without literally learning any type of programming. Okay. And here we have the think bubble instead of the hello say bubble. And it really is just changing the bubble type. Instead of a speech bubble, it changes into a thought bubble. You can change the size by 10, making the sprite bigger. You can also just reset the size back to 100%, which is the normal size.